In this lecture, you will learn about constructing strong research questions and hypotheses, basic research designs, and threats to validity. Anyone can ask any question, but not all questions are research questions or RQs. In general, if you have a strong RQ, research question, you can build a strong H1, a research hypothesis. A strong H1 should consist of three major components. First, it should include specific variables of interest. Second, it should be brief. Any research question or hypothesis that is extremely wordy or lengthy is probably not focused. Third, it should be testable and measurable. What is the difference between a research question and an H1? Your H1 is simply the research question stated in declarative form. For example, if your RQ is, "Are men more prone to road rage?" your H1 would be, "Men are more prone to road rage." We begin with a research question, RQ, and then change it to declarative form in order to transform it into an H1. The most simple way to create an H1 out of a research question is to simply transform it into a statement instead of a question. Now, review the three components on this slide. Does the example H1 meet the criteria? Is it a strong H1? The answer is no. Although it is stated in declarative form, it does not meet the other criteria. How do you measure more prone? That's too vague. Who are you comparing men to? When and where? We could improve this H1 by making it this way. Road rage is higher among men than women on Houston freeways in 2014. Not only is this a strong H1, we would also consider it a directional H1 or directional hypothesis, since we have specified the relationship between road rage and gender. For example, men have higher incidence than women. Furthermore, we would have to operationalize road rage in terms of specific behavior. We could measure road rage by the number of car honks per hour. This is measurable and would be your dependent variable, or DV. You could record the number of times per hour that male drivers honk their horns and the number of times female drivers honk their horns on one or several Houston freeways. Gender is a variable with two levels or attributes, which are male and female. Gender would be your independent variable, or IV. If using an exploratory design, you will have a research question, or RQ, but not have a hypothesis, or H1. This is because when you use exploratory designs, the hypothesis is not generated until after your data analysis. However, if you are using a quasi-experimental or explanatory design, you will have both a research question, RQ, and a hypothesis, H1. You must also use your knowledge about levels of measurement and statistics to decide which statistical test is most appropriate to answer your question and/or test your hypothesis. You must take into consideration, are you generating versus testing theory? What is the most feasible way to carry out based on time limits, setting, population, etc.? What is the most ethical way to proceed collecting and testing your data? Carrying out social work research is tedious and requires a lot of forethought, consideration, and planning before it is carried out. Good testable research questions always begin with your curiosity. What relationships are you curious about? What variables in the world puzzle you about which you would like to learn more about? Let's take an example from a recent policy issue in our Texas legislature. Last legislative session, our leaders introduced Senate Bill 11, or SB 11, which allows concealed carry of firearms by students, faculty, and staff on public college campuses in Texas. Take a look at the images in the next few slides. These are the recent events of gun violence that inspired this bill. The legislature did pass this bill and will go into effect in the fall semester of 2016. Now we will take a look at some images to get a context for and history of the passage of Senate Bill 11. Many people were curious about the relationship between firearms, college campuses, and violent crime prevention. This is something you can develop into a research question that is testable. Okay, now let's build a strong RQ out of our topic of interest, violent crimes on college campuses. Look at the example on this slide. This research question is, what are guns like on campuses after gun policy? This first RQ does not meet the criteria of a strong RQ, so it needs some improvement. If we revise it to how high are crimes on campus after gun policy, would this be a strong RQ? It is stronger than the first, but does not meet the criteria for a strong RQ. The type of crime is not specified, and remember, crime can be nonviolent or violent. We need to be specific about what how high means, which campuses we're referring to, and which specific gun policy we're referring to. The third RQ is strong as we specify what type of crime we're interested in. What is the average rate of violent crimes on Houston college campuses in 2016 after the passage of HB 11? Now that we have our research question, we have to decide on a sample and sampling technique. Deciding on a sample and sampling technique is part of the methodology in carrying out a research study. Imagine we collect violent crime data from 3 college campuses, such as UH Clear Lake, UH Downtown, and Texas Southern, to use as our samples. We might select these campuses because it's convenient, since we live in Houston and have easy access to these campuses. This sampling technique is a non-probability method referred to as convenient sampling. How many participants do we have here? The answer is 3. Remember, in this situation, the most feasible way to collect violent crime data on campus is not to hand out surveys to all students on all 3 campuses. Instead, what is most feasible might be to work with each campus police department who collect data on the number of violent crimes per month. In addition to deciding on a sample and sampling technique, we must also determine what is the most appropriate and feasible research design to use. Again, the X stands for the bill that was passed, Senate Bill 11, allowing students and teachers to carry guns on campuses. X also represents the IV, or independent variable, which is the passage of the bill. The O1 is your dependent measure, or dependent measures. In this case, violent crime rate on campuses. Since the campuses are various sizes, it is wise to compute a violent crime rate as opposed to using the raw numbers of violent crimes. Again, since the campuses are all different sizes, if we used raw crime numbers, we could misinterpret the larger campuses as having more violent crimes. We can compute rate as X number of incidents each month per 1,000 students. Using this calculation allows us to compare apples to apples, so to speak. Answering this question would require an exploratory design, since little is known about this phenomenon, and we are exploring relationships. Remember, your dependent variable is considered scale or continuous level of measurement. This is because violent crime rate could be 0 technically, and there is the same distance between data points. For example, a 40% violent crime is twice as much as 20% violent crime, etc. If we collect violent crime data every month in 2016 for each of the 3 campuses, there are 2 types of statistical tests we can run. To answer our research question, we can calculate averages, means or medians, of violent crime across campuses using univariate descriptive statistics. We might also create an additional research question to see which campus had the highest crime rate. If we wanted to compare the three colleges to each other to compare monthly violent crime rates, we could also run a one-way ANOVA. We would use a one-way ANOVA because we would be comparing three different groups. In research, there are many ways to test relationships between variables. Now, let's look at another example of going from an RQ to a strong H1 within the same topic. Look at the first example. Do guns make campus better? This RQ is weak, so let's make an improvement in the H1 to make this more specific and testable. Our H1 might be guns on campus impact crime. Now this is an improvement since it specifies what exactly is impacted on campus, which is crime. However, this first H1 still has weaknesses. For example, it does not specify the type of crime, again, violent or nonviolent, which types of campuses and when. Let's revise and improve this H1 too. There is a relationship between guns and violent crime on Houston College campuses. This is a bit stronger, but it lacks specificity. This is an improvement, as we specify what type of crime we're interested in, which types of college campuses, and the general period of time. There is a relationship between guns and violent crime on Houston College campuses in 2016. Look carefully at our H1. What are the two variables in our H1 here? If you said guns and violent crime, you're correct. Here, the O1 is your measures. Gun carrying rate on campus, as well as violent crime rate on campus. Those are your dependent measures. Now that you have the research design correct, the multi-group post-test only design, what is the statistical test you need to use to test your H1? Remember, both of your variables are considered scale or continuous levels of measurement. This is because gun rate and violent crime rate could be 0 technically, and there is the same distance between data points. If you said the statistical test you would use is Pearson's R, you're correct, because you are collecting data on these two variables and testing the theory the legislators had when they created this bill, that there was a relationship between gun carrying rate and violent crime rate. You would use a Pearson's R statistical test to test your H1. The Pearson's R statistical test is appropriate because you are testing the relationship between two levels that both have, between two variables that both have scale or continuous level of measurement. Imagine we ran a Pearson's R between these two variables, gun carrying rates and violent crime rates on college campuses, and our p-value was equal to 0.03. This p-value indicates a statistically significant relationship between these two variables since p is less than 0.05. The R tells us additional information about the strength and direction of the relationship between variables. Since R is positive, there is no negative sign in front of the 0.67. That means that as gun carrying rates on campus increase, violent crime on campus increases. You can also see the strength of this relationship by referring to your statistical tests handout, which indicate a moderate relationship. In other words, your findings would not support the intent of Senate Bill 11. Remember, those legislators believed that increasing the number of guns on campuses would deter violent crime. Sometimes our data reveals support for what we or others believe to be true. Other times, our data refute that knowledge. How can a social worker use research? This is a good example of how our research can inform advocacy and macro-level change. We can also calculate the amount of overlap between variables using a Pearson's R. We simply square the R, which is timesing it by itself. This will give us the R squared, which is known as the coefficient of determination. Once we square the R, move the decimal place over twice to the right, and you just converted it to a percentage. In this slide, we would interpret the R squared as 44% of the variance in violent crime is explained by the variance in gun carrying rates on college campuses. What that basically means is that these two variables explain much of each other. On the other hand, more than 50% of the variance in violent crime on campus is explained by other variables that we have not tested yet. It is rare that just one variable can explain 100% of another variable, mostly because relationships are complex. However, finding what explains at least 30% of a phenomenon is considered quite good. We use future research to try and find out what the other 50% plus consists of. Now let's look at the specific threats to validity of this particular study. Refer to your textbook and the Threats to Validity handout. Remember, exploratory designs have the highest levels of validity. The highest threats to validity. Exploratory designs have the highest levels of threat to validity. Threats include what we call extraneous variables or error, which can cause threats to the conclusions that you can make about your particular study. All research studies have threats. Some we can control for before our studies start because we can predict them. We call this constant or systematic error, while others we cannot control for. We call this random error. These threaten the conclusions we make about our study in terms of the impact of an intervention, event, or manipulation, or any real differences or relationships that truly exist in the universe. Okay, so what do you think are the threats to validity specific to this study? The three main threats to validity are listed on this slide. Let's discuss each one. History. History could have been a potential threat. This type of threat is considered random error. You could not have predicted it before your study. For example, let's imagine that during your study or data collection, the University of Houston gained a large grant that added more security officers on duty. This threatens the conclusions you can make about any real relationship that exists in the universe between legalized gun carrying and violent crimes on campus. Instrumentation error. Since you would have to depend on the campus police departments to collect your data, there might be flaws in how the police department collects the data on violent crimes and gun carriers. Perhaps not all the student or teacher gun carriers registered their guns with the campus police department. Perhaps not every violent crime on college campus is reported to the campus police. This causes instrumentation error and can also threaten the conclusions you can make about the relationship between your two variables of interest. heterogeneity of variance. Again, because your 3 campuses are so different, perhaps TSU student population has an age range of 18 to 86 in terms of student population. Then, the other university may have a student population of the age range of 18 to 44. The heterogeneity or differences within TSU, for example, might obscure the relationship between your 2 variables of interest. Be sure to review the threats to validity and research designs often, as this information will be very important for you to know in terms of the content for this course. Remember, every study has threats to validity. There are no perfect studies. The important part is that you can identify the specific threats to your study and try to control for as much extraneous variables or error as possible. Let's give you some more practice identifying threats to validity. Take a look on this slide and you will see a Dilbert comic. Read the dialogue in the comic and identify the specific threat to validity that is referred to. Use your Threats to Validity handout and textbook to help you. If you guessed restriction of range, you're correct. This is the right answer because only giving 3 choices to answer an item presented does not capture the full range of self-description in the universe. This might obscure any real relationship or differences between variables that you are testing in your H1. This concludes the lecture on research questions, hypotheses, designs, and threats to validity. Please email or stop by with any questions.